Sahana Bhogapur, a student of CIFAR department, here to present the topic on image classification using CIFAR10. So first let us understand what is image classification. Image classification is a task given to a computer to categorize the images based on its vision contents. So I am using CIFAR datasets. So CIFAR stands for Canadian Institute for Advanced Research. They have taken 50,000 images and categorized them into 10 classes. So this dataset helps us to classify efficiently. So first we start by importing the packages. Here TensorFlow is used for deep learning. It is used for deep learning. We are importing the CIFAR10 from TensorFlow dataset. In here, we are splitting the training set and test set differently. And when we ask for the train shape, it is giving us the output 50,000, 32, 32, 3. Here, 50,000 is the image number of images there, and 32, 32 are the pixels, that is 32 into 32. And 3 is the color channels, that is red, green, and blue. Y train is of 2 dimension. So here we only want some indexes. How it will print, we are going to see by giving y train dot phi. Here it will print only the set of arrays. Then here we are defining the classes. Here we are importing the matplotlib to plot the graph. So how we are going to do with an example is for first we are going to define sample x, y and index. This plot I am show x index shows the image of the index where it is located. So we have 50,000 images. So from that which index we give as the input, that index image will be taken for an example to show the output. Y train will contain the name of that class corresponding to that image. So after defining, here we are using x train, y train, 53 index we are using. Here we are normalizing the x train and x test dividing by 255. Here we are doing this because 255 is the number of pixels used. By dividing to 255, we are going to range it from 0 to 1, which will help us to normalize the data, which will help us to train the data easily, more efficiently and faster way. By building a model using sequential, here we are going to build a model. Here we add a conventional layer. Here you can see con2d, which helps us to reduce and split discriminations. After this, we print the model summary where it will give us the total model summary of how many outshapes we have and how many this we have. So the 53rd will be a truck. So here you can see in the images it has detected as a truck. This is the graph. After this, we are going to compile the module and save it once. To train this model still more, we are going to use 10 epochs. Here we are training it by 10 epochs, which helps us to train it more efficiency. Here we can see a loss and accuracy of this. By training this, we can make sure it makes less errors. After this, we are evaluating by how much percent does this efficiency test is taken. Here we can see the output. Then we are using prediction test. By seeing that accuracy, we are going to model predict where the x test, the number of the output average, the accuracy it can, we are going to use for prediction. These are the classes that are used. Pics should be in the form of 32 to 32, so we are going to reshape some. Then we are going to save the model in my model h5, which will be saved. So now we are going to install Streamlit, where we are going to run for. So After installation, first we are going to write this whole file into app1py by using the function write file, which will directly write the file into app1 file. Here we are importing the modules. OS provides us a interactive with operating system, and CD here is a open CD, that is computer vision, which helps us in the image processing. NumPy is helped in the calculations. And here field is used for importing the images, and Streamlit is for the website we are creating. These are the classes name that we can that images we can upload in here. So we don't have to rerun the whole module. So we are going to save it in the cache module. Here in the module, the rerun module will be saved here itself. After this, we are going to give a name for the web, that is image classification with the CIFAR10 dataset, and we are going to upload the images. Here in import and predict, first we are going to set the size, that is 32 by 32, and if the image fit the size, it's okay, but if doesn't fit, we are going to reshape it according to our prediction, because our data set is based on 32 into 32. Then we are going to click on the prediction button, then file will open, and then it will give the prediction according to the class name we are given. So let me run it. So first here I am uploading the dog image. After uploading, we have to click on predict. Here we can see it has predicted image mostly same as a dog. Similarly, we can also upload another image. Here I am uploading an image of truck. Then we have to click on predict. We can see the image mostly